Alrighty, guys. So this week we're going to kick off our lessons with Chapter 10, Section 1, titled Chemical Quantities. All right. Hopefully, the opening assignment you performed well, and you're ready to just get started with this new material. All right. So let's proceed forward real quick. Let me just fix that. There we go. All right. We're gonna just skip a couple of these slides. All right, so with 10.1, we're going to figure out, how to approach problems that consist of trying to convert from one unit to another unit. And we can term that as dimensional analysis. Now, in the beginning of the semester, or I should say the beginning of the year, we practice doing so. In the beginning of the year, we practice dimensional analysis. Now that we come to the end of the year, we're going to revisit those same things, but now we're going to apply a chemistry twist to those things with new terminology, which is pretty fascinating, and hopefully we can, proceed forward with wisdom and knowledge. All right, so when moving on with dimensional analysis, keep in mind the following steps. Number one, anytime that I give you a question where I ask you to figure out the units, and values of a given value that already has a different unit, the first thing you want to answer is what is given. All right, what in the problem do we know? Number two, the next thing you want to figure out is, okay, well, now that I know what I have, what is the question asking of? What units do I want as an end result? Number three, we want to come up with any possible conversion factors. Number four, we're going to now situate our conversion factors accordingly. All that means is providing an algebraic expression that we can make as an equation to figure out what we want. And then finally, perform the work, perform the algebra. All right, let's go to practice problem number one. All right, as this lecture proceeds forward, the problems are going to get tougher. So we're going to start off very, very easy. All right, the first question. What is the mass of 90 average size apples if 1 dozen of the apples has a mass of 2 kilograms? All right, 2 kilograms. All right, like we said in the previous slide, I'll go back really quick. That first slide is saying, number one, what are we given? That's the first thing we want to figure out, or that's the first thing we want to write down. All right, step one, let me just, all right, that's good. Step one. All right, what's given? All right, at the top of the problem, it says, what is the mass of 90 average size apples? All right, that's the first thing is given. We have 90 apples. All right, we have 90 apples, and we know that 1 dozen of apples has a total of 12 apples. So, one apple, I'm sorry, not one apple. 1 dozen equals 12 apples. All right. So that's what's given. We know we have 90 apples. We know that 1 dozen equals 12 apples. And we know that 1 dozen of apples equals 2 kilograms. All right, those are the two equalities we know. That's what's given, those three pieces of information. Part 3 asks for us, part 2 asks us now, okay, well, what units do we want as a result? What do we want as an end product? We want to figure out mass. All right, and mass in this case is going to be kilograms. All right, so we are starting with we want to go from apples to kilograms. Step 3, we're going to make those conversion factors. All right, so 1 dozen over 12 apples, and that equals to 12 apples over 1 dozen. The other set of conversion factors is 1 dozen equals 2 kilograms, which equals 2 kilograms over 1 dozen. Those are our two sets of conversion factors. Part 4, set up the algebraic equation. All right, so we're going to start off with what's given, which is 90 apples. And we want kilojoules at the end. That's what we want at the end. All right, so we're going to get rid of our apples by converting them into dozens. So we're going to figure out which conversion factor to use from this area. All right. Since apples is on the top over here, we want them to be at the bottom down here. So 12 apples under 1 dozen. Those apples cancel out. Now we're at dozens. So now we want to convert our dozens to kilograms. That means that we're going to use one of these. All right. So dozens is on top here, so we want it at the bottom over here. 1 dozen. We're going to use this one. 2 kilograms. The dozens cancel out. Now we're left off with kilograms is what we wanted in the end. Notice that the units we end off with are the units that we want. All right. So now you pull your calculator out and you do 90 divided by 12 times 2, which is a grand total of 15 kilograms. All right, that's question number 1. Let's go on to the second one. All right, number 2, assume that 1 dozen oranges has a mass of 1.5 kilograms and that there are 14 orange slices in each orange. How many slices are in 6 kilograms of oranges? All right, so the first step, as always, is going to be listing what we know. All right, so we know that, okay, assume 1 dozen orange has a mass. Okay, we know that 1 dozen equals 1.5 kilograms. All right, that's the first piece of information, and we know. And we know that each orange, 1 orange, equals 14 slices. And we also know that we are starting off with 6 kilograms of oranges. All right. The second part now is, okay, well, what do we want in the end? All right. And a lot of the times, in order to figure out what the ending units we want to look at that last question. How many slices are in 6 kilograms of oranges? We want to go from mass, in this case, which is kilojoules, and we want to go to slices. All right, so slices is what we want as an end result. Step 3, we're going to make those conversion factors. All right. going to be 1 dozen over 1.5 kilograms. And the same is true for the reciprocal. 1.5 kilograms equals 1 dozen. All right. And then the second set of conversion factors, I'm going to do this in a different color. 1 orange equals 14 slices, and 14 slices equal 1 orange. All right. And I think that's all we need. And if we need, we can, make the conversion factor of 1 dozen to 12 oranges. I don't think we need that though. All right, step 4 and 5 consists of doing the algebra. We're going to start off with what we know. We have 6 kilograms. All right, we want to convert those kilograms to dozens. Well, remember, we want slices at the end. We want slices at the end. All right, so we're going from kilograms to slices. Kilograms to slices. All right. All right, so the first thing we want to do is we want to convert our kilograms to dozens. So we're going to use one of these bad boys. All right. Which am I going to use? Let's use it. Oh, well, let's stay consistent. All right, 6 kilograms. We want to go to dozens. If kilograms is on the top here, it needs to go on the bottom. 1.5 kilograms, and 1 dozen is going on top. So the kilograms cancel out. Now we're at dozens, and we are going to need that additional conversion factor, which is 1 dozen equals 12 oranges. All right. All right. So in order to get rid of the dozen, we're going to put the dozen at the bottom. 1 dozen equals 12 oranges. Dozens cancel out. Now we're at oranges. We're going to use one of these. All right. If we're at oranges and we want slices, we're going to convert our oranges to slices by using a conversion factor that has the orange on the bottom, which is this guy. Slices at the top. All right, oranges cancel out. Now we have 6. Let's write that over here. We have 6 times 1 times 12 times 14, all divided by 1.5. All right. 6 times 1 times 12 times 14, and I did write the answer because I did the problem already. Oh, well, let me pull my calculator out then. 6 times 12, 14. Yeah, I can't find a calculator. All right. Well, do the math on your own. Wait. Where is my calculator? There it is. All right, so it's 6 times 12 times 14 divided by, what was it divided by? 1.5. divided by 1.5. 672 slices. That's how many slices we have. All right. Now, as a freebie, I'm going to do the problem from the work from today, or from, Monday. I'm going to do this really quick. All right, so it takes a total of 112 donuts to make what's called a sugar forest. By the way, there is no such thing as a sugar forest. I made that up. All right, sugar forest is just something I thought was funny because I love donuts, and I was trying to think of some arbitrary, funny, random name to call it. Sugar forest is completely made up. It's fictional. All right, so your boy came up with that. Pretty impressive, right? All right, it takes a total of 112 donuts to make what's called a sugar forest. One donut requires a total of 92 grams of flour, and you have 19 million micrograms of flour in storage. If 1 gram equals 1 million micrograms, do you have enough flour to make a sugar forest? All right, I'm not going to go through all the steps because I'm going to save you the time, but I am going to cover a couple of them. So first and foremost, we have a requirement. At the top, we want to see if we have enough dough to make 112 donuts. All right, so I'm going to start off with what we have. All right, we have a total of, what do we have? One donut requires, and you have, okay, we have 19 million micrograms. That's how much flour we have. We have that many micrograms. The first thing I'm going to do is convert that to grams. All right. So for every 1 gram, we have 1,000,000 micrograms. All right. For every 1 gram, we have a million micrograms. Micrograms cancel out. Now we're at grams. Awesome. Now that we're at grams, the next thing we want to do is we want to convert